Okay, 11.5. Objective. Students will be able to solve problems involving geometric probability. So here's a basic idea. Let's say you have a box here, right? It's 2 by 2, the blue box. And then there's another box inside there that's 1 by 1. If we wanted to find the probability of a point being chosen at random inside this box, and it actually being in the green box, we would take the target area and divide it by the total area, or the area of the 1 by 1 over the area of the 2 by 2. So that's where we get this target area over total area. So the green would be our target area, and the total area would be the blue. Okay, so what if we get a problem like this first one? It says a square game board has black and white stripes of equal width as shown. What is the chance that a dart thrown at the board will land on a white stripe? And let's just assume that a dart thrown at the board will hit this board. Okay. Well, at first glance, this looks really kind of crazy. But here's what we can do. Let's zoom in, and let's draw a series of lines. Let's break it up into chunks. And I'm putting in the yellow lines here, and I know that this probably need to go over this with some other darker lines. So let me put in the black lines too. On the white, yeah, so it's a little bit easier to see. All right, now we can kind of see what's going on here. We have a whole bunch of little blocks. Oh wait, one more right there. We have a whole bunch of blocks. In fact, we have 6 by 6 blocks, or a total area, remember target area over total area, of 36, and we'll just say little square units. Okay, so what's the chance of it hitting a white stripe? Well, how many white units do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I have 15 unit squareds there. Now my unit squares get to cancel each other out, and I just have 15 over 36, which reduces, I could take a 3 out of each of those, reduces down to 5 12. So my probability is 5 in 12. And if I wanted to figure out that in a percentage, because sometimes we talk about probability as a percentage, I could just go to my calculator, do 5 divided by 12, and I would get approximately 41.6 repeating percent. I guess that's actually exactly 41.6 repeating percent. And there we go. We have the probability. It's just a little bit over 40%. Okay. Well, let's look at the next one now. This one tells us how to find the area of a sector. And a sector is like a pizza slice of a circle. And all we need to do is we need to take the angle, the central angle, and put it over 360 degrees. And then times that by our formula for the area of a circle, pi r squared, and we'll get some portion of the circle, right? So for this next problem here, it says find the area of the top sector. Well, this is the top sector here, the blue one. I'm going to kind of draw around it here. So that one has an angle measure of 46 degrees, central angle measure of 46 degrees. So for part A, the area of that blue sector, the top sector, is 46 over 360 times pi r squared. Well, what is my r? Well, it says the total distance up and down is 12. Therefore, my radius must be 6. Okay, well, we can work this out. We could take a 2 out of 46 and 360 and give me 23 out of 180. And 6 squared is 36. And then pi. Notice I kind of flipped the order around of these two things because the number is supposed to go in the front. All right, well, let's work this out a little bit because I can actually take a 36 out of 36 and out of 180 because 36 goes into 180. In fact, 36 times 5 is 180. So if I take 36 out of both of these, I'm left with a 1 and a 5. And so I get that the area of this sector is 23 pi over 5 units squared. And there we go. Now I have my area. Well, they want us to find now the probability that a point chosen at random lies in the top sector. So out of the total area, what's the probability that it lands in this part? Okay, well this isn't going to be that difficult, because remember, we can just take the target area and put it over the total area. So target area, again, 23 pi over 5, divided by the total area, which is just pi r squared. We have it right here. It's 36 pi. And you should see right away that these pi units are going to cancel out. And so you really just have, let me fix that real quick. That's a 23. So 23 fifths divided by 36. And you can kind of think of this as 36 over 1. So you could write this as 23 fifths times 1/36. And 5 times 36 is 180, so we get 23 out of 180. Now that is our probability as a fraction. But what if we wanted it as a percentage? Well, again, we could just put in our calculator, 23 divided by 180, and we're going to get 12.7 repeating percent. So it just depends how they ask for it. Either one of those can be listed as our probability. We often use probability as fractions, but sometimes we'll talk about it as percentage as well. So there you go. Let's go on to the next page. Okay, example number 3 says a regular hexagon is inscribed in a circle with a diameter of 14. So I went ahead and drew this already in here. And if the diameter is 14, we could kind of draw that across here, which means that from the center to the outside corner here, it is 7 and 7. Okay. They want us to find the area between one chord from the outside of the hexagon and its corresponding arc. Well, that would be like what I have shaded in here. One of these little sections right here. So let's think about what that would be. If I was to think about that as an area, that would be the area of the circle minus the area of the hexagon. And that would give me all of these, but I have 6 of them, so I'm going to have to divide this total thing by 6. So then let's write out it as an area formula here. So it's going to be pi r squared minus 1/2. The area formula for a regular hexagon is 1/2 perimeter times apothem. This works for all regular polygons. And then remember all of that divided by 6. So let's see, what information do we have? Well, we do know the radius, actually, because it's just from the center to the outside. That's 7. And so 7 squared is 49. So we actually know that it's going to be 49 pi minus 1/2. Do we know the perimeter? Well, let's see. Let's zoom in on this figure again. Actually, we do, because we can draw in all these lines here. And we know that hexagons specifically get cut up into a whole bunch of equilateral triangles. So that means that all of these sides are actually 7. Okay. Well, if that's true, then our perimeter is just 7 times 6. All right, then. 7 times 6 is 42. And now we just need the apothem. Okay, so let's figure out what the apothem is. Let's go back to our figure here. Remember the apothem, see if I can get another bright color to draw in here. The apothem goes from the center to the center of one of the sides. Well, if this was an isosceles triangle, then this angle was 60, and this angle was 60, and now this is 90, and now each of these are 30. And so that would make this side 3.5, and that would make our apothem 3.5 rad 3. All right, well now we have our apothem, so let's plug that in. 3.5 rad 3. Okay, but remember this is all divided by 6. Okay, we could simplify this a little bit, but it's not going to get much prettier than this. So we could just go ahead and go straight for the calculator if we want. If we were going to simplify it, here's what I would do. I would write this as 49 6 pi. And then I would figure out some of this. A half of 42 is 21. And 21 times 3.5 is, let's see, 21 times 3 is going to be 63. And half of 21 is going to be 10 and a half. So 63 and 10 and a half is 73.5. Divided by 6, rad 3. Okay, and now we just have to figure out what 73.5 divided by 6 is. I went ahead and did it already. It is 12.25. It's kind of hard to get much simpler than that. So we go to our calculator, we plug that in, and we get that total area of just this little sliver here is about 4.44 units squared. Okay. Now what? Well, part B says, find the probability that a point chosen at random lies in the region from above. Okay, well remember, this was all just part A. Now we're going to do part B down here. If we want to find the probability that a point lands in this area, we need to do the target area over the total area. So let's take a look. My target area is 4.44 units squared, where my total area is a circle. So it's just going to be pi r squared. Again, my radius is 7. So we already worked this out. We know the total area, I should have a unit squared down there, is going to be 49 pi units squared. Unit squareds cancel each other out. And so you're just going to do 4.44 divided by 49 pi. When you plug that into your calculator, you're going to get approximately 0.0288. And so that as a percentage is 2.88%. There you go. That is how you'll find the probability of hitting that little section. So the main thing that we got to learn or remember is that it's just target area over the total area. And that'll give us the probability. All right, see you guys on the next video.